everyone. Thank you so much for joining us today for our second monthly webinar Wednesday, featuring our fantastic guests for this month from IUCN. We have Kathy and Phil. They are both senior program officers with the IUCN SSC Conservation Planning Specialist Group. So I'm going to just read their bios quickly, and then we'll get right into the presentation from them, and hopefully this will work a lot better than last week. Kathy Traylor-Holzer is a senior program officer for the IUCN SSC Conservation Planning Specialist Group. After working for 18 years in conservation and research at the Minnesota Zoo, Kathy joined the CPSG staff in 2002 and serves as facilitator and population modeler for CPSG workshops, especially those focused on integrating species conservation planning and risk assessment for wild and captive populations. Her interest in the genetic management of captive populations and ex situ contributions to conservation complements her role as stud bookkeeper and population management advisor for regional and global captive Sumatran and Amur tiger populations, and as advisor to the cooperative breeding programs for tigers, orangutans, and giant pandas in Asian zoos. She is a co-author of the IUCN Guidelines for the Use of Ex Situ Management for Species Conservation and specializes in tools for the integration of in situ and ex situ conservation activities. And she will be the first speaker we have. And then Phil Miller is a senior program officer also with the IUCN Conservation Planning Specialist Group, which is, as you may not know, an advisory conservation organization that's part of the Species Survival Commission, SSC, of the IUCN. Academically trained as a population geneticist and conservation biologist, Dr. Miller has demonstrated particular expertise in the use of simulation modeling techniques for developing population viability and disease risk analysis across a diverse taxonomic range and against an equally diverse human cultural background. This experience is an outcome of his involvement in the planning and implementation of over 70 risk assessment workshops in 40 countries around the world. In addition to these analytical responsibilities, Dr. Miller has developed expertise in facilitation skills, where he has served as a species conservation planning workshop designer and facilitator. He has also served on a CPSG team that teaches both analytical and workshop facilitation skills to conservation management specialists from around the world. Dr. Miller has developed an effective teaching methodology that he uses extensively in CPSG's workshop processes centered on capacity building and technology transfer. In addition to this training role, he's developed teaching packages for use in more traditional settings that focus on training students in many theoretical and applied aspects of conservation biology. So everyone, we are excited to welcome our speakers here today. If you have any questions for them, we will have 15 minutes at the end of the webinar for you to ask questions. And those questions can be typed in the chat feature, and I will be managing those chats. So please type your questions in, and we will start our presentation now.
Great. Well, hello, everyone. Thank you very much for joining us today. Both Phil and I are delighted to be able to give this presentation. And as you can see in the title, the focus is the one plan approach. And we hope to describe the what, the why, and the how of effective integrated species conservation planning. And I'll be giving the beginning, more overview and some of the methodology description in this presentation, and then Phil will show you wonderful examples of how this has worked successfully in practice. So first, we'd like to start out today to tell you just a little bit about who CPSG is and why we're talking about the one plan approach. For those of you that may not be familiar with our organization, we're part of the IUCN, the International Union for the Conservation of Nature. That's the largest global and conservation organization in the world and the oldest, and it's made of 6 commissions, as you see represented here. One of those is the Species Survival Commission, or SSC, which is made up of over 8,000 volunteers that are technical and species experts for species around the world. Within that commission, there are over 140 specialist groups. You may be familiar with many of those or members yourself, but they tend to be taxon-based specialist groups, for instance, the primate specialist group, or one for corals or for cranes. And one of as well as those taxon-based specialist groups, there are several discipline-focused groups, and the Conservation Planning Specialist Group, or CPSG, is one of those. The SSC is well known for the red list. You may be familiar with how species are assessed and assigned levels of threat on the red list. They're also responsible for action plans and conservation plans for species under their remit. CBSG was how we started out, as the captive breeding specialist group. And so our specialist group is 40 years old now. We started out as a group of experts that helped zoos and aquariums primarily around the world with demographic and genetic management of species. And then as regional zoo associations took on that role themselves, we morphed our skills in population management over to applications for wild populations and became the Conservation Breeding Specialist Group, still known as CPSG. And just a few years ago, in 2016, we were given the mandate from the Species Survival Commission to help all specialist groups and other conservation planners and managers in developing conservation planning for species and trying to develop effective ways to move forward to save species. And so throughout all of that, we are actually, I'm not sure. We have used the same three principles of sound science to base our decision making, neutral facilitation, and then also stakeholder inclusion. And I believe it looks like there's not animation in these slides, so hopefully you're seeing the whole slide here. But please write in the chat box if the animation isn't coming through on your end. So, and so with that, with the stakeholder inclusion, that includes not only many of the relevant stakeholders, governments, landowners, field biologists, and conservation planners, but it also includes the situ community of zoos and aquariums as well, who we've involved throughout all of our history of conservation planning. So traditionally, many times, conservation planning is done both in situ and ex situ in two silos. And so wildlife managers, field biologists, landowners, and those types of specialist groups have developed recovery plans or conservation plans for species and populations in the wild, and then may or may not have considered the ex situ community in those decisions or as part of their tools. On the other side, often zoos, aquariums, botanical gardens had developed their own management programs, thinking mostly about sustainability and about other uses of those populations, and then secondarily, perhaps, how might this contribute to conservation? And so, of course, there have been some species that have very well integrated those efforts from the beginning, but they've often been done independently with occasional crossover. And so what CPSG has tried to particularly promote is the idea of integrating these efforts from the very beginning. And so instead of working in two independent streams, to have all of these specialists in a species that work with the species, that have knowledge of the species, to work together and come together at the beginning to look at what are the true conservation needs and then how those needs might best be met. And so this would then bring those different stakeholders together to develop an integrated conservation strategy. This would include conservation actions for the wild populations, and then in some cases, if appropriate, also use ex situ management activities to meet some of those conservation needs, with the goal of them all coming together to produce actions that lead to viable wild populations living in healthy ecosystems. So this idea of integrated conservation planning has been termed by CPSG as the one plan approach. It's not a new idea. Many people have been doing this for a long time, but it's something that we've been trying to particularly emphasize and promote in both the in situ and ex situ communities, and put a name to that approach in 2011. And so what at least CPSG means by the One Planet approach is integrated conservation for a species both inside and outside its natural range and under all conditions of management, engaging all the responsible parties for the species and all available resources. And ideally, this would be done from the very beginning of a conservation planning initiative, so that everything is developed in concert with each other and synergistically with each other. And so there are many benefits to the One Plan approach. One of those is that it enhances global collaboration between all the stakeholders and communicating all aspects of conservation planning and its implementation. It can accelerate the evolution of conservation planning tools. It contributes significantly to the achievement of the IUCN biodiversity targets. And ultimately, it promotes more effective conservation for the species through making the best use of tools available and expertise available. So one of the tools that CPSG has been involved in developing is a revision of IUCN's guidelines on the use of ex situ management for species conservation. These guidelines provide a decision process to evaluate if ex situ activities or programs should be established for conservation purposes, and if so, what might be the structure of those programs. It provides a transparent, structured decision process, whether the decision is that programs should or should not be used for conservation. It can be applied equally whether or not there's an existing population held ex situ. It can be applied to all taxa, including plants, invertebrates, all living species, and in all different kinds of forms. So they can be living animals, or they can be, for instance, gametes or seed bank. And it's available in multiple languages, both on the IUCN website and also on CPSG's website. These guidelines outline a 5-step decision-making process, and it's similar to the same type of decision process you may use in other conservation planning. The first step is to review the threats and the current status of the wild, and in this case also any ex situ populations, and what are the real conservation needs of that species or that taxon. Then we look at all the potential conservation roles that ex situ might play and which ones might be useful. Potential roles for that species that would address the constraints on that species' viability. The process then looks at the characteristics of those programs and what would they really need to look like to fulfill those potential conservation roles. The next step is to look at what resources would be needed, how feasible it is to actually apply these programs, implement these programs, and what are the risks, whether they be biological, political, financial, or whatever. And so at that point, you look at a balance between the conservation benefit and then the cost, risk, and feasibility of the program, and make a final decision of whether or not this is a potential conservation action you might recommend for a species as part of a more holistic conservation plan. And so what these guidelines try to do is really open up the conservation toolkit. So there's a lot of tools in our toolkit, whether it's building habitat corridors or controlling invasive species, et cetera, that people often think of when you have particular threats for a species. And what these guidelines try to do is to open up that toolkit, look down deeper in the box of maybe tools you didn't realize you had or didn't realize they would be appropriate or had forgotten about, and to look and say, would these also be useful? That doesn't mean ex situ management tools will always be appropriate for every species. Sometimes all you need is a hammer to do a job and you don't need an Allen wrench. But if you need an Allen wrench, it's nice to know it's there, and that might really make the work more efficient. And so we're trying to open up that toolbox and make sure everyone considers all their options. So there are several different some common conservation roles for XE2 management. Many of these, they're outlined in more detail in the XE2 guidelines. The first three on this list, the ARC, insurance, and rescue roles, are ones that really are looking at different aspects of species that are in critical situations in the wild. Maybe there is an imminent threat that you need to establish a rescue population before that species is wiped out. Maybe you need a backup insurance or ARC population because they're disappearing or even extinct in the wild. The next two on this list, the demographic manipulation and the population restoration, address situations where you still have an existing wild population that might be out of balance in terms of demography or genetics or numbers, and you can use an XE2 population as a source to help restore some of that balance and stability. The next two on the list, the ecological replacement and assisted colonization, are ones that deal with our changing world in terms of habitat conversion or climate change, and you may need to use a different species to reestablish a lost ecological function, or perhaps to assist the species to move to other areas where the suitability of habitat has moved geographically. Finally, the two on the list, the XE2 research or training or education, may address very specific threats or very specific changes in human behavior that can lead to increased viability for a species. So how can these different activities really help in a threat situation for a species? So on the right here, there's a progression often for species where there are primary threats such as disease epidemics or habitat loss or poaching that might lead to small fragmented populations. This in turn might lead to low reproduction and survival, to inbreeding, and establish a feedback loop where the smaller the population, the worse these stochastic effects become, which then again can cause further population decline and fragmentation. That might lead to extinction in the wild, and if none are held in situ or XE2, then species extinction entirely. And so on the left are 4 different ways that are bulleted that might intervene at different places along that progression of threat for a species. So some of the roles I mentioned earlier might address the primary threat itself or address data gaps that can help address that threat. There are other roles that might address the imbalanced small fragmented population and offset some of the low reproduction or survival or genetic problems. There are also roles that help to restore populations and keep them from going extinct in the wild, and there are ones that prevent species extinction entirely. And so depending upon where a species is in that continuum, there could be multiple roles that different XE2 populations have the ability to address. So how do you decide? How do you actually take this document, this decision process of the XE2 guidelines, and apply it? And so on this slide, there's really a continuum of how it can be applied, and I have a few examples, moving from the left of a fully integrated component of a species recovery plan, such as this recovery program that was done for the harp eagle in Brazil, where you had a working group that during recovery was looking at XE2 components of that recovery plan. All the way over to the right, where you may do a less detailed assessment, but you do multiple taxa. And so moving left to right, there have been cases where, for instance, there's an existing recovery plan, and for the power chic skipperling butterfly, we're able to do a separate XE2 component that then feeds into an existing wild plan. There are ones like the next one, the parrot, where there were related taxa that had similar threats, similar problems, and similar solutions, and you could address several taxa at one time. And then on the furthest right is a new process, an integrated collection, assessment, and planning process that's being adopted by regional zoo associations, particularly the European Zoo Association and others, and was developed in collaboration with them to look at many related species, maybe all of them within a certain family or a certain order, and look at kind of a less detailed, more generalized assessment and prioritize which ones are appropriate for conservation action. The most appropriate, the most important component here is no matter how you apply these guidelines, that they're done using both input and participation of both the in situ and ex situ community to look at the best ways that these tools might improve the viability of the wild population. And then finally, just to give you some ideas of how this approach has been communicated, it's well entrenched now in the zoo community. And so on the left, the conservation strategy of WAZA, the World Association of Zoos and Aquariums, is based upon the one plan approach. There are many articles and book chapters that from the zoo community side that have really embraced this, from the book that says the Ark and Beyond on the right to a recent article on the ICAP process in Zoo Biology, the Journal of Zoo Biology. There has been an article in Conservation Letters of the SCB journal that talks about these guidelines. We have in press right now a chapter in the Encyclopedia of the UN Sustainable Development Goals that talks about ex situ conservation and addresses many of these points that we're making in this presentation. There was also a recent webinar that goes into more detail about how to do an ex situ conservation assessment, and you'll see the web address at the bottom of the screen on our CPSG website where to find that our seminar. And then finally, for any of you that might be going to the ICCB meeting in Kuala Lumpur this July, I'll be there to give an oral presentation on this multi-species rapid assessment tool called ICAP that integrates both the zoo, aquarium, and botanical community with in situ experts for rapid multi-species ex situ conservation assessment. And so hopefully these give you some ideas and some overview of what we mean by the one plan approach. And next I'm going to turn this over to my colleague Phil Miller to give you some detailed examples.
Hi, everybody. Kathy and I had to do a little technological change here as I moved over to her computer. My headset wasn't working as well on my machine as hers is on hers. So anyway, I'm in the captain's chair now. I just wanted to, on behalf of Kathy, thank Sarah in particular and the Society for Conservation Biology and Debbie Luke for the opportunity to talk to you about this initiative that we have. We're really excited to bring it to you first here kind of conceptually, and then hopefully we can actually start working together on a number of different issues related to integrated management of endangered species. And so along those lines, I do want to talk a little bit about how we integrate some of these programs in a series of examples that are going to be spanning a broad taxonomic range, but also spanning a broad range of different types of ex situ program management for effective ultimate species conservation in the field. So before I get into that, I just did want to bring up the existence of a variety of manuals and guidelines that have been produced by our parent organization, the Species Survival Commission of the IUCN, and all of these different guidelines that have been produced over the last 7 or 8 years or so have been really instrumental in increasing our knowledge and understanding of how to implement effective species conservation in the wild across a number of different disciplines and a number of different types of tools and processes. Starting in 2012, the reintroduction guidelines put together by the reintroduction specialist group were instrumental in helping us understand how to improve our relocation and translocation and reintroduction efforts. And then starting in 2014, in particular, the Conservation Planning Specialist Group had the real joy of being participants in the development of a series of these different guidelines, ranging from, as Kathy said, the ex situ guidelines for management of these ex situ populations for conservation up through disease risk risk analysis, protocols and tools and processes, and then finally in 2017, developing a broader array of species conservation planning guidelines. So we use all of these in our work in developing integrated conservation plans for endangered species, and I encourage you to look through these as you explore your own needs and interests around this broad topic. Ooh, that doesn't look very good. It's kind of hard to read some of the material on the screen here, but essentially what I just wanted to reiterate the fact that Kathy talked about a variety of different tools for, or different purposes for captive populations and ex situ populations. And what I wanted to do here is give you a series of case studies that we personally as CPSG have been involved in to show you the different types of roles that different populations can play and how we have helped people work through the process of determining the kind of optimal roles for these different types of populations for effective species conservation. And one of these, we can start off in Tanzania with the Kahanzi spray toad. This was a process that we were involved in some years ago. The Kahanzi spray toad is endemic to an extremely small area, about 2 hectares of rainforest habitat at the base of the Kahanzi River waterfall in Tanzania. And a dam was constructed along that river and led to dramatic changes in the habitat characteristics of this forest, which led to a subsequent dramatic crash of the population. And in fact, the last wild spray toad was seen in 2004, which led to the classification of the taxon by the IUCN as extinct in the wild. And so, but fortunately, in about the year 2000 or 2001, the Bronx Zoo initiated a captive program for the species, captive propagation program, which was then followed up by the Toledo Zoo. And that successful ex situ propagation program then led to the successful reintroduction of a relatively small number of individuals back into the wild once the habitat was rehabilitated essentially at the base of this waterfall. And additional release efforts are now currently underway to bolster that population in the wild. So here's an example of essentially preventing extinction of a species in the wild through the initiation and establishment of an ex situ population and successful demographic and genetic management of that taxon for releasing the population back into suitable habitats in the wild. There's also a very important research component, as Kathy noted, that ex situ populations can serve. An important research effort in North America revolves around understanding white nose syndrome, which is a fungal infection of bats first observed in the U.S. in 2006 in the northern regions of New York State. And the map there shows that there's been a dramatic expansion of this fungal disease, which has now killed over 7 million bats in the United States across multiple cave ecosystems. And there has been a real urgency in trying to understand the epidemiology of the disease and how we might best manage it. And so researchers at the University of Wisconsin in Madison, Wisconsin, have initiated a captive research population of little brown bats, which are extremely susceptible to this fungal infection. And they have been really successful in developing a series of research efforts which are now showing real promise to develop and test a potential vaccine that can be administered in situ in the field for protection against these fungal infections in wild populations. So the ex situ population, even in a research institution like what we see in Madison, is now really instrumental in helping us understand the epidemiology of the disease and its ultimate management, hopefully initially at the local level, but then potentially more at the regional level. A similar type of situation presents itself with the Tasmanian devil. in the states of Tasmania, in Australia. Many of you have probably heard about this situation where the wild population since about 1996 has been decimated by essentially a viral transmissible cancer that is highly lethal to individuals that are exposed and contract the cancerous form of the disease. And in order to stave off extinction before the disease and the pathogen swept its way across the entire island, a series of efforts were undertaken around the year 2000 or so, a little bit after that, to create a series of essentially ex situ enclosures. So we're not talking about the traditional type of zoo environment, but we're talking about a series of ex situ enclosures where disease-free individuals were identified, removed from the wild population where they were highly susceptible, and then put into these essentially exclosures as a rescue population, so that in the face of this extremely lethal emerging threat, the population and the species may be able to sustain itself. And there are now probably 600 to 700 or so individuals that have been distributed across Tasmania and in certain parts of Australia, mainland Australia, where we now have these exclosures of disease-free individuals that may be used as suitable release candidates when devil ecologists and devil habitat biologists can deem a particular region in the range of the species to be suitable for release and reestablishment of disease-free populations. There's some new evidence coming out now that there could be some potential for natural processes to help reduce the prevalence of the disease. There's essentially a natural selective process that may be ongoing currently, but the establishment of this rescue population was vital to develop genetically and demographically healthy populations of the species that can then be used to reestablish those same types of healthy populations in the wild once we understand more about how to diagnose and manage the threat. So again, ex situ populations, in this case, in these semi-situ, if you will, exclosures have been extremely valuable for broad species conservation. This is a very interesting case in Florida, central Florida in the United States. It's a species called the Florida grasshopper sparrow. And currently there are about 35 to 40 breeding pairs of this critically endangered bird in the wild that are threatened by a number of different ecological and predative factors. And in response to the significant threat, a couple of ex situ institutions in Florida collected individuals in a rescue population operation, essentially, and held these individuals and began propagating these individuals in an ex situ environment. Unfortunately, a severe disease, a pathogen, essentially a gut parasite, coccidiosis, and also a microfilariid infection began to show up and cause significant mortality amongst individuals that were being bred in captivity. So that immediately raised a question of essentially disease risk analysis and disease risk management. What is the likelihood that this is a novel pathogen that perhaps the captive population was able to pick up through interaction with other birds or other closely related taxa in that captive environment? And if it were a novel pathogen, what was the probability that release of these individuals back into the wild through a typical kind of reintroduction program or augmentation program could actually introduce a novel pathogen into the wild population, which would of course be highly undesirable for both that taxon and for related taxa. So this, in this case, the captive population, the ex situ populations played not only a rescue role, but a really important research role to understand the disease in an ex situ environment, the probability of that pathogen existing in an in situ environment, and how we might be able to better understand the integrated management of this particular species so that we could have a much better opportunity for successful recovery of the species in the wild. And then Kathy talked briefly about the butterfly example, and I just wanted to show a couple of slides where we actually go through using the ex situ guidelines in some detail. Here's a kind of tabular example of some of the products where we identify the different threats that the species faces in the wild in the upper part of the Midwestern United States, as you can see in the column headings. And over in the row headings, we've got different ex situ population options that Kathy talked about, and we can identify which of those options may be best suited to help mitigate or ameliorate some of those threats. And then once we go through that particular process, then we can drill down in more detail into a particular ex situ management option, in this case, an insurance population option. And again, talking about the feasibility and the pros and cons, the positives and negatives, the risks associated with establishing a particular type of population, ex situ population or ex situ role, in the context of how that particular role could best deal with the threats and what the feasibility is for that particular role. And that feasibility is both biological and social, economic, regulatory. A number of different issues come to light in a discussion around the application of these ex situ guidelines. And they're really developed to not only talk about the biological aspect of management, but all of the different criteria and all of the different axes that you need to think about when you develop these integrated management programs. And then what was interesting about this particular example is that over when we asked the group of the group of experts managing Poweshiek skipperling to develop a 5-year plan, they came up with a really interesting plan that featured a series of different types of ex situ roles that included immediate head starting of individuals, where we would bring individual females into an ex situ environment, allow them to lay eggs. Those eggs are then allowed to hatch and develop in an ex situ environment that could then be used to repopulate or augment wild populations, the same population from which they were derived. You could also have some research on successful breeding in an ex situ environment using a surrogate species, in this case, the Dakota skipper, which is not as endangered, but has a similar breeding biology. Once that information comes to light, you could then try to develop a successful insurance population, a breeding population of the endangered species, which could also be used to further our understanding of research on parasites and disease in the captive populations and their wild population counterparts. With all that knowledge and with that proper insurance population generation, we can then really think about how to reinforce existing populations in the wild and perhaps establish new populations in the wild that could then significantly improve the viability of the species in situ. And while that was going on, this group decided that they may want to develop a contingency plan for developing a rescue population. In the midst of doing all this other work, they thought, well, we might need to develop a rescue population if there is a new threat that significantly impacts and significantly increases the risk of extinction of that population. So they looked at a number of different potential ex situ roles that have very different purposes and also may be initiated at different points in the continuum of management across, in this case, a 5-year period. So it showed a nice progression of use of ex situ roles over the lifetime of the management strategy. I wanted to finish with a couple of examples where we integrate the largest number of tools that we have within our conservation planning specialist group toolbox to look at how we integrate captive populations or ex situ populations with their in situ counterparts. And we do this through traditional risk assessment methodologies focusing on population viability analysis, where in this case we used demographic risk assessment tools and technologies to evaluate the value of head starting in an endangered turtle in the northwestern United States, where there is an intense head starting effort underway by Seattle's Woodland Park Zoo and the Oregon Zoo that is trying to mitigate the intensity of the threat, the predation threat posed by invasive bullfrogs. Bullfrogs will eat anything that they can put in their mouth, and they significantly reduce the reproductive potential of this turtle by eating a lot of the new hatchlings that come out of the nest at the appropriate time in the breeding season. So the zoos are head starting these individuals, taking the hatchlings out of the nests, raising them up in captivity, and then putting them back out so that they can get through that really intensive predation risk period and dramatically increase the abundance of turtles and their long-term viability that is occurring within the additional activity of trying to reduce bullfrog abundance, because of course we can't just head start this population without dealing with the ultimate threat to the species as a whole. So we use these various types of predictive demographic tools, in this case our Vortex population viability modeling tool, to evaluate what intensity of head starting is necessary in conjunction with or in tandem with different levels of bullfrog population mitigation, to determine what types of activities are required to improve the long-term viability of the species. And this was done in an even more intensive way when we were looking at developing a feasible recovery strategy for Mexican wolves in the southwestern part of the United States and northern Mexico, where there is currently a population of wolves in the southwestern United States and a small, known as the Mexican wolf experimental population area, or MWIPA. And then there is the Sierra Madre Occidental population, small population of wolves currently being established in Mexico. And there is also a well-managed, genetically and demographically well-managed population across North American zoos. So we have a very strong ex situ breeding population that is being used as a source population for introducing animals into these wild populations. And we were able to use our modeling tools to evaluate different intensities and different durations, as you see in this diagram, in this table here, different types of release strategies for integrating the ex situ population very explicitly with their wild population counterparts, and also evaluating the relative success of different translocation options between wild populations. And we could then identify the intensity of breeding necessary in the ex situ populations in order to serve the needs of the wild population community. And once we develop these different types of scenarios, we can then evaluate the demographic trajectories of future population abundance under different types of management strategies. And we can also look more importantly, or as importantly, at the level of genetic diversity retention that can be expected when you do these particular types of integrations of populations across the in situ and ex situ spectrum. So again, another example of how we're very explicitly using these populations for reinforcing existing wild populations, establishing new wild populations, and using our predictive tools to determine how best to manage those populations in a demographic and genetic context. So again, kind of a very detailed but yet a very successful operation of essentially application of one plan approach to help the U.S. Wildlife Management Agency develop an effective recovery planning process for Mexican wolves. And we're currently doing this with whooping cranes in North America and other species as well. So that was a series of examples of how we might use this type of approach. We've developed and we have internally published a book called Second Nature, which is available for digital download on our website, that has many of these examples in it and others that I didn't talk about today. But I encourage you to go to our website, cpsg.org. You can learn a lot more about the one plan approach, and you can look at the different types of case studies that are exemplified in our Second Nature book, and also more importantly, look at the reports, the workshop reports of all of those different examples that I talked about today, where we facilitated the implementation of that one plan approach to develop some effective species conservation strategies. So feel free to poke around our website and learn a little bit more about what we're doing in the integration of these different types of populations. So we're looking forward to be able to talk to you with some questions. We may have to do a little bit of headset swapping here periodically since we only have one headset and two people, but we're certainly more than happy to talk to you about and answer some of your questions about our presentation today. So thanks on behalf of Kathy and I. Thanks very much for your attention.
Great. Thank you so much, Phil and Kathy. This was really, really interesting. And I am excited to hear you answer some of these questions from our captive audience. So here's a first question for you. There's a lot of information missing for some species that are facing population reductions. Where would you recommend starting with those species? In other words, for some species, there isn't a lot of info on threats, either in situ or ex situ. Where do you begin if you want to implement this approach?
Well, since I got the headset, I'll give a quick initial shot here on that, and Kathy can chime in. That's going to be a very, very common situation where we don't have as much information that we would like to have on the nature and the intensity of threats and their mechanisms. There can always be an opportunity to look at other types of perhaps closely related taxa, or taxa that live in the same geographic area where there may be some of that kind of information, where you could perhaps draw information from other related taxa, or both taxonomically related and spatially related, and adapt that information as available to your particular situation. In the absence of that type of luxury, if you will, there needs to be some expert judgment and expert elicitation of best available information to begin to develop hypotheses, essentially, about the types of threats and their mechanisms, and then use the various types of analytical and facilitative tools we have available to test the validity and the feasibility and the utility of those different types of assumptions about how different threats affect the particular species of interest that you may be working on. It's always going to be a problem, and we have to do the best we can with making decisions with less than perfect information, and it becomes a process of hypothesis testing and iterative analysis and management implementation.
Great.
Thanks for the question.
The next question. What is your experience of applying the one plan approach to freshwater and marine species? The key problem is that there are few threatened marine species in captivity, so it's hard for zoos and aquariums to behave in the same way as they have with terrestrial.
Okay, we were just trying to determine how to answer these.
Sorry.
Yeah, no, that's all right. Yeah, I mean, there has been some work recently, and in fact, one of the examples that I could have talked about was we've done some freshwater fish work, again, in the southwestern part of the United States, where we're evaluating the effective use of hatchery activities to augment native fish populations. Again, in our situation, it's been freshwater fish, and that type of hatchery activity can be extremely helpful from the demographic augmentation standpoint, right? So you can really improve the demographic structure and the abundance of fish in a wild population through integration with the hatchery population. There is some caution, I think, though, that's necessary when we want to talk about the genetic structure of the individuals that are used for release, because you could have a highly skewed genetic representation among those individuals that are selected for release from a hatchery situation, where you may not have the type of optimal breeding structure that you might want in an otherwise more carefully genetically managed program. So they can be extremely valuable one plan approach components. I think there is some additional genetic management needs that have to be addressed when those types of populations are being used in that type of one plan approach capacity.
Great. Okay. Next question is, how best can we communicate what IUCN is doing to the public for those of us in science communication? With the recent news of the IPBES UN report, which is terrifying to the public, how can we best motivate them to help in your efforts?
Yes, it's like how do we communicate to a number of people the value of this approach, particularly in terms of the IPB report that just came out.
Hi, this is Kathy. I just put the headphone back on. So I'm hearing the question is, how do we communicate about this approach rapidly? And so, we're trying to get the word out, and things like this seminar, the other seminar, I gave the link to publications, conference presentations, but certainly we're trying to, particularly in the in situ community of wildlife managers, approach as many organizations, governments, etc., to try to get them integrated. In the ex situ community, we're encouraging the committees and the managers to not make their own planning in isolation, but to make sure on their steering committees, for example, in their planning activities, that they approach the SSC specialist group, they approach the wildlife managers and field biologists, and certainly in the programs that we do, the workshops we run, we make sure there's an in situ and ex situ voice in everything. And so I would say the same thing is true for in situ experts that are doing conservation planning or recovery plans. If they have the appropriate ex situ experts on their planning committees, consultants, even if it can't be done face to face, it can be done electronically nowadays, and make sure it's not just a one-off thing, but that they're integrated in the decisions as the planning goes along.
Great. So next question is that the SCB audience here and everywhere seems to be extraordinarily diverse. Do you have any examples outside of the US and Australia of these plans? Even the spray toad example seemed to rely on US institutions.
Sure. So in terms of more diversity geographically of these plans, at least ones that we're familiar with or have been involved in, for example, there's Iberian lynx in Europe, was well integrated in terms of in situ and ex situ roles and modeled in many ways like the Mexican wolf. In Brazil, the harp eagle example I gave was for harp eagles in Brazil, and as they developed their in situ conservation action plan, national action plan, they involved ex situ roles. In fact, Brazil is a country right now where a lot of the national action plans that have been developed, either at the same time they have an ex situ assessment or after the fact. I just came back from following up on the Amazon parrot example in Brazil, where they're integrating their national action plans with ex situ assessments of how do you deal with confiscated birds, how can they be used to benefit conservation and not have a negative impact on conservation. Wattled crane in South Africa and southern ground hornbills are ones in South Africa I can think of offhand. And in Asia, we're starting to do this with pangolins. The giant panda ex situ program in Asia, for example, has looked very specifically at insurance and population reinforcement roles and even in research roles. So I think there are examples in all continents, and it's more an issue of trying to get the word out and have different planning agencies adopt this type of approach.
Great. I think we're going to have time for 2 more questions. So the next one is, you state that in all in situ and ex situ teams should be involved in the process. However, many national park systems are severely strapped in terms of funding and human resources. Can this process be scaled in such cases?
Sure. So in terms of trying to involve both in situ and ex situ when you have limited resources and funding for do that. One way, some of the ways I mentioned, for instance, is if you have if you're an ex situ group, you have an in situ at least advisor or partner in your committees, whether it's your recovery team, whether it's your species management committee, but both sides of these two communities would benefit from having a representative from the other community as part of their planning structure, their planning committee. Now, that can always be done face to face. If the meetings are infrequent, it would be great if they can participate. More often not, or there might even be legislative restrictions of who can be on these committees. But things could be done virtually, either by Skype or GoTo or some other kind of discussions. What we've done in some of these massive multi-species planning workshops, the ICAPs for regional zoo associations, if we can't get field experts from all those different taxa there, because you couldn't have, say, 40 or 50 different species experts from the field there, we would try to communicate before a workshop or planning process, do a quite specific detailed survey of how they think XE2 might benefit conservation efforts in the field, and at least bring that information into the discussions within a more collaborative workshop setting. So I think virtually, and it's one way to do it, and then just trying to make both types of experts part of the planning, long-term planning teams.
Great. So we might have two questions left. So maybe just one. We'll see how long this one takes for an answer. But so the for disease-free individuals, this person agrees that they should be considered a priority. But how do you think of animals as genetically healthy? How do you define genetic health?
Okay, I'm going to answer this one and repeat the question, and then hand this headset to Phil. He can add if he likes, and then he can take whatever the final question is. So disease-free animals are one way to look at animals that are used for these approaches, but as far as genetically healthy animals, how would we define that? And so I would say if you're talking about taking animals from the wild into an XE2 situation, kind of depends on what your purpose is. If you're trying to do disease monitoring, maybe you want a random sample. If you want genetics, it would be good to take not a whole family group or social group, but you want animals that represent as much as possible a random sampling of the population. So you may want to look across the geographic range of that particular taxon so that you get different kinds of genetic complements that you bring in to captivity. And then you would want to manage those animals, again, depending upon your purpose, but in most cases, you want to breed them in a way that maximizes genetic diversity in an XE2 setting and minimizes selection to captivity or genetic drift. And so you would avoid inbreeding between relatives, and you would try to retain as many different alleles or genetic traits that you brought in from the wild. You would try to retain them in the same proportions in captivity. That way, it's not only a genetically healthy animal, but it's a genetically healthy population that you're trying to maintain, both sampling from the wild and maintain in XE2. And so with that, I'm going to hand the headset to Phil for the last question, and if he wants to comment or not on the last question.
Yeah, again, sorry for the passing the torch here, but yeah, I mean, the only quick thing that I would add to Kathy's really good answer is just there are now molecular techniques that you can use to better understand the genetic constitution of individuals that you might bring in to initiate a captive or XE2 population, both in terms of their disease status and the genetic underpinnings of those disease status data, but also looking at the relationships among individuals that you can try to better generate a founding population for an XE2 program that has as much genetic diversity and minimize relatedness to the extent possible.
Great. Thank you so much for that very comprehensive answer. So I think that'll be our last question.
Okay.
So for those of you that have more questions, if you'd like to send them to me directly, my email is attached in the webinar invite. I'm Sarah Weber. You can also look me up on conbio.org. for my contact information. I'll try to get those questions if you have any more to Phil and Kathy. But Phil and Kathy, thank you so much for your time today. We really appreciate it. And thank you everyone for tuning in. This was recorded and it will be sent around to everyone at the end. So thank you for joining.
Excellent. Thanks very much, guys. Appreciate it. Bye.